All right, welcome everybody to Computer Science 5500 Foundations of Software Engineering. And here we are, we're going to start our journey. So today is the first module in the course, or the first lecture. Some of you are going to be watching something similar to this live tomorrow on Wednesday when we start. And others of you will catch up and watch this later. So it's going to be the same content, so you don't have to worry. But it's just going to be all the content for the week posted today. Now I'm going to send out an email about how this course is going to work, and so I just want to dive right into it so you know what's going on. Some of you are going to be attending in class on Monday and Wednesday. On Mondays, when you're in attendance, we're going to start off the lecture with a sort of review of what the lecture is about. It'll be sort of very brief and quick. And then it'll just be an office hour period where you can work with me, your classmates, the TAs might join remotely, and so on during that class time. Wednesdays will be very similar, except we'll be talking a little bit more about the lab for the week. There will be labs released every week, and we'll spend the first half sort of introducing, showing what the goal is of the lab, how to get the lab, those sort of things. So we'll go over some of those things today. So this is our first class, so there'll be a lot of sort of logistics things to go over. But week to week, there will be a pre-recorded lecture with all the lecture content released, so you can watch that at your leisure. And then again, Monday with a sort of lecture and review, and office hours, and Wednesday with sort of a lab review and office hours following. All right, so I'm going to pop out of here and show you where you can begin, and welcome to Computer Science 5500. Okay, so now that I'm out of the screen, I'm going to navigate you to our website here. In the top right corner, you can go to Teaching Foundations of Software Engineering, and you'll find our course here. And this is really the course webpage. If you haven't taken one of my courses before, the key thing to look at is the schedule or the roadmap here. If you have taken one of my courses before, this will look very familiar. I'm always updating things, but this is the key thing here. So we're going to go over this content shortly, but I just want to go ahead and navigate us to Module 1 here. So you can click on it. So there'll be a brief outline for the week that we're in. We're in the first week, which started Monday, September 7th. Technically, our first day is, well, today, Wednesday, September 9th. But go ahead and click Begin Module here. And that'll bring up the module. Now, on our schedule and roadmap, I'll also put all the assignment due dates here. We have assignments due roughly every week or so for the first part of the course before we get in the final project, and then a lab that's due every week. Okay, so let's go back into Module 1 here, and there's a couple different tabs here which you can click on, but you'll usually start each week by looking at the readings to do before class, and these are different readings that'll help you just understand or be prepared for what I'm going to talk about in the lecture. So you can look at those. If you want a little bit extra practice, you can click on the Test Your Knowledge section, which will usually have a ungraded quiz if you just want to do this for some reinforcement. Consider this a sort of beta feature. Sometimes I have these more in-depth than others, but that's there for you. But what you'll want to do during class, or since we're online at some point, is you can access the slides from the Slides tab. Any code samples I show in the slides typically go in this GitHub repository. And then there'll be an in-class activity for you to do at the end of class. And then since we're online, of course, you have 1 week since the module was released to finish this in-class activity. This first week, it'll be a little pre-class survey. Okay, so let's go ahead and dive into the slides and start with the lecture portion. Now I will mention sometimes I will be better than others about breaking the lectures into small pieces. Of course, because you're watching online, do take a break, pause, run it at 2x speed if I'm talking too slow, run it at half the speed if you need to slow things down. That's totally fine. That's the advantage of being online. So do be sure to take advantage of that. Okay, so a little pre-class warm-up, something I would like you to do. And since we're not in person, I'll facilitate this on Piazza. But take a moment to introduce yourself online, introduce yourself to your classmates. We'll do this through a Piazza post, which I'll show you now, and just let them know what your name is, maybe what you're excited to learn about, or a favorite piece of software. Okay, so I'm going to go ahead and create the Piazza post for this and show you where that is on the course webpage. I'm going back here and clicking on the forum board. Most of you should have already been added here, but if you haven't, then I will make sure to do that, or you can do that yourself here. So let me log in to Northeastern. And once you've logged in, you should see the 5500 course here for Foundations Software Engineering. And you should also see the 000 board where I post various opportunities and notes. That's something you can opt out of if you like. Okay, so our first icebreaker for our pre-class warm-up is to introduce yourself. Okay, so once I've written this Piazza post here, I will just click a category to put it on and post here for everybody. So for the icebreaker, feel free to comment under this post. You can like things and so on. Okay, so now we all know how to use Piazza, and I'll talk a little bit more about that as we go along here. Okay. Okay, so we're obviously recording since we are online, and today again is our introduction. Okay, so we kind of just dove into things, but what about your instructor? I've introduced myself very briefly here. And occasionally you're going to see me pop up in the camera like so at different places. Usually I'll put myself in the corner here so you can see me. But do I actually know anything about software engineering? Why am I the person who's teaching this class right now? Well, I want to tell you a little bit about me if you don't know. Okay, so I first got into computer science by trying to figure out how to make games. That's sort of my origin story. I played games, and then I found out I liked messing with them and tweaking them, and just figured out in a Google search like this that I'd need to figure out programming, and then I learned some art and some music and all these different components of games and really enjoyed it. So that happened around middle school. Then I started writing tutorials for a gaming magazine. Really found out I enjoyed teaching computer science at that very early on as well. Did undergraduate at the Ohio State University, and there I got into various research on using games to help people, and then eventually medical visualization stuff, which led me to interests in sort of graphics and systems. Somebody told me, Mike, you should go grad school. I said, what's grad school? And then eventually wound up doing my master's and PhD, which was a journey you can ask me about another time if you're interested in pursuing further graduate school, like a PhD degree. And now my interests again are in systems, graphics, and performance. That's where I have sort of worked in as a academic. But I've also worked a lot in different places. So the Supercomputer Center sort of at Ohio State, obviously Tufts for research, Oregon Health and Sciences, spent about a year at Intel, some time at PlayStation. Oblong Industries is a Los Angeles and Boston-based sort of graphics, mixed reality, sort of interesting company. If you've ever seen Iron Man or the Minority Report movies, they're the ones responsible. And then some other companies here. And then more recently, I've been doing some consulting work with a company called 4D Pipeline on various graphics projects. Okay, so the places where I've worked on software and been a software engineer is, well, everywhere here. So lots of different places. I have lots of different stories I'm going to draw from these various workplaces. And I hope that's something that you can learn from. And many of you also have some professional or internship or co-op experience that I hope you can also draw from to share with your classmates and make this an awesome course. And then last but not least, I am of course a Northeastern Husky doing software engineering here. Now I'm not alone in this course. I won't be the only person who shows up. You will have interactions with two awesome teaching assistants who I've known for a while now, Rahul and Amit, and they will be introducing themselves later on through probably office hours, but they might pop in the first classes and some of the live streams if they're available. You're also very likely going to be introduced to our instructional assistant, Miles Wilson. So thank you, Miles, for getting the room set up for those who are attending in person through the NU Flex model. Again, that'll be on Mondays and Wednesdays during our normal class time. Will essentially be the first few minutes review of the lecture or the lab that's taking place for that week, and then office hours or sort of open discussion on anything that comes up. Okay, so there are other sections of CS 5500 with Professor Bell, Mitch Wand, and I believe Frank Tipp also has a cross-listed section with the undergraduate section. And they're doing different things, so our assignments aren't quite going to line up, meaning I'm doing this course in C++. They're doing their course slightly differently, I believe in TypeScript, different project, and so on. So they're, doing different things that are both interesting, so you might find out after a week you like one section or the other, and if there's positions available, go for it to switch. But ours, we're going to have a lot of fun in this section. Okay, so what is this course now that I'm talking about it in my section? Well, we kind of have to define software engineering first. And this is something I, try to think a lot about what it means to be a software engineer. So I'm going to pop in here and kind of ponder what this is. I actually just looked for a definition of it, and I was able to find one. It was from IEEE, and it reads the following. Software engineering, the application of a systematic, disciplined, quantifiable approach to development, operation, maintenance of software. That is the application of engineering to software. So the last bit, application of engineering to software, implies that there is some sort of process that we can follow, or some things we can sort of put in our toolbox and not necessarily use as the only way to do things, but just have some different tools, so when it comes time to build software, we'll have a few ways to approach how do we build something. Okay, so sort of what's in a name. The Shakespeare idea here is in this course, again, we're just going to learn some foundations and principles that are widely known and used in practice. Things like design patterns, strategies for organizing our code, ideas about how to design software, again, before we write the code, so it'll save us time. And this has been shown time and time again. We'll look at a few case studies that designing your code and thinking about it before just jumping in and writing code is usually the right idea. And many of you might be nodding your head in agreement if you've ever found yourself in a sort of deep trial and error session of coding. And we'll talk about what that actually has a pattern to it, the code and fix pattern. We'll talk about later. So what we're going to be studying is how to build software, and you're going to have to engineer a new product in this class. So you're going to have to make some design decisions and understand different trade-offs that you're making while going through the software engineering process. Okay, so roughly speaking, the course content, I can divide it into 6 or so categories that really take place heavily in the first, I would say, 10 weeks of this course, and the last few weeks are more project-based, but the first bit is just getting used to our developer ecosystem. We're going to be learning C++. The expectation is most of you have never used C++ before. If you have, that's great. If you haven't, no problem. That's what we're going to start doing. Some version control stuff if you're not familiar with Git, or maybe have used a different system, you'll have to get familiar with that. And then just how to build your software. So how do you compile software? How do you test it, using systems like Make or CMake, for example. Then we're going to talk about how we iterate through our software with the software engineering lifecycle or software development lifecycle, the agile way, I guess if we can give it a name, but waterfall might be okay, so we'll talk about those sort of trade-offs. We're going to spend a good chunk of time talking about design patterns, and again, ways to organize our code or solve problems. They're not a be-all, end-all solution, but they give us some patterns that come up frequently enough that they're useful to know. Okay, Then we'll talk about how to define requirements, some different design principles. Yes, UML, how to structure our code before we design it, and then a few different testing and debugging strategies for tools that can help us. Okay, so depending on how far you are in your CS career, whether you've done an undergraduate degree already or have worked for several years, or maybe this is your first course in the program, you're going to have different experience in each of these domains. That's great. So you might know some of the things and be able to share them, or you might learn all this stuff from new, and that's okay. Okay, so for this project, so I've sort of alluded to, this is our first really 10 weeks or so of going through a lot of this stuff, and then the rest is working on course projects. So the company that you're going to be working for or have sort of scored a contract with is going to arrange you in a team of 4. Okay, so you're not the CEO of this company. You've been hired to do some work, and you're not going to really get to pick your teammates. I'm going to help you pick them based off of time zones and things like that, since we're all remote. The company has other specifications. For example, this company that's hired you and they're going to pay you a lot of virtual money wants you to do it in C++. So we have to learn C++ in this class to implement our project. Okay, so we have to use the company's sort of restrictions or constraints that they've given us in the C++ language, and we have to use their tools. So they use Git. Okay. So the project you're working on is going to be realistic. I'm going to give you the sort of statement of work that reflects consulting work that I've done. So again, just real stuff. But the requirements that you're going to get are going to be intentionally vague in the sense that you don't always know all the requirements or what the software is going to look like or all the little things that you're going to need to do until you actually dive in and do some of the engineering. So you're going to get some high-level requirements of what the company's hired you to do, but figuring out all the teeny tiny steps to get there, well, that's up to you, and that's why the company's hired you, because you're smart and can figure it out. Okay, so the company's budgeted enough money for a project of about 8 weeks. That's about when we'll start. So you get that much time, and then we'll do a little bit of final presentations during the last week. With the food provided, that's sort of at your discretion at home, and the final presentations probably being in video form, but we will join to try to watch those. That'll be the goal if feasible. Okay, so that's a note on teams, the project, and some of the organization of the course. Again, why am I sort of putting you on random teams? Well, that's what you get in real life when you get hired with a company. You don't always get to choose, so I'm going to try to choose something reasonable since this is an online course. In the sense that we'll try to put folks in the same time zone or that have the same constraints together. Okay, so now that we've talked a little bit about that, let me point you back at the website and let's talk about some of our course goals. Okay, so I'm going to switch over to msha.io. That's where the website will be. If you forget, you can Google my name and then over to teaching in the top right corner, Foundations of Software Engineering. Okay. So some of the basics here, the course name, semester we're in, and Piazza. Please use Piazza. I get nice batch emails of all the questions that are asked. It is easier. I lose stuff less. You can post code links there. You can post a link to your repository in a private post. Just makes life easy here. So please use Piazza. Here's the schedule again. Modules are released every Monday. There'll be a lecture review on Monday and office hours, and then on Wednesdays there will be a lab review and office hours then. Okay, the location is sort of NU Flex, so many of you will be online participating remotely. Some of you are going to be completely remote, and that's fine. Okay, so whatever you're comfortable with will be facilitated. So here's me, here's my email. Primarily use email for personal matters. If you're feeling unwell, have to travel for some reason and know you're going to miss class, let me know. If you have a doctor's visit or dentist or whatever, and know you're going to miss some time, that's okay. We have some flexibility again. I'm sort of breaking things down into 1 week at a time for you to complete the work. okay? And I'll try to be as diligent as possible with the deadlines, posting them here. So as long as you can watch the material, communicate with your teammates when that time comes, and complete the assignments by the due dates, which are posted here, you are good to go. And just a note that due September 16th anywhere on Earth means literally anywhere on Earth where it is still September 16th. So looking here, let's see, it's about 1 a.m. where I currently am, which is still, well, I'm on the 9th right now, and this somewhere in the world is still on the 8th. It is 4 p.m., okay? So that's how that works. So roughly gives folks in the Eastern time zone till sometime on September 17th, early in the morning. Okay, other logistics here in the course description. You've read this part, but in general, this is a project-based class. Here, I'll put myself on the screen so you can see me talking to you. This is a project-based class. You're going to work in a group. You're going to work with a team. It's very hands-on. We're going to be doing lots of sort of assignments and labs, as I think that's a great way to learn. So hopefully you'll learn a lot about learn and retain a lot of information about the software development lifecycle, different design patterns, writing tests, and these sort of things, okay? The prerequisites, because you're in the course. Just a note on academic integrity and non-discrimination. Even though we're in an online environment, these rules still apply. Being fair to your classmates, and also in an online space, just creating a place where we can be friendly. Remember, all of our classmates, and being kind to them is super important in the online space. Office hours for those attending the class. I don't think we'll have any problems with this group. I've rarely had any problems. So if there are things we can do to make it a better space, let me know. But otherwise, we do follow the Student Code of Conduct and Northeastern's policies here. Okay, on makeup policies, so following along here, I'll move where I'm talking. If you do know something's coming up, some sort of university sanctioned event, let me know. No problem facilitating that, but I can't just give you an extension if you need one, unfortunately. I have to be fair to your classmates. I have to make sure that's, deadlines sort of help you move along and move with the class. So there's just a small 10% penalty if you are late on something. Again, I try to be very fair with that, okay? But please let me know if there are other life circumstances that prevent you from moving forward. Okay, accessibility, as I'm moving down here. Northeastern tries its best to facilitate ways for you to be successful, so if there's something that helps you perform better in the course, please let me know. We have a resource here at Northeastern, as well as WeCare, just to take care of your general wellness, which I have a note about down here. Super important, this course should be fun. That's always the goal with the courses I teach. You should have a lot of fun and learn a lot. Let me know if there are ways to help facilitate that. Okay. So again, on lateness and attendance, folks who are going to do well in this course, this online course, are going to participate actively, attend office hours, and also set some deadlines for themselves to say, hey, I am going to watch the video, by Monday night at 7 p.m. Eastern time every time. In general, I'll be releasing them Monday by or Sunday nights. So try to adhere to that schedule. Give yourself a schedule. It can be Wednesday morning, it can be Thursday night, whatever it happens to be. Just folks who do well tend to follow the rigorous schedule or more rigid schedule, especially in the online courses. Okay. Course policies and assessment on grading here. Here, I'll get rid of me so you can pay attention to this. We have in-class activities that you complete after every lecture. We have in-class labs, which I will talk about today, and you'll begin, which are due 1 week after they're released. So these will be released again every Sunday or so, and you'll have a week to complete them. We'll have an exam for this course, which you'll take online. I'll talk about that as we get closer. assignments, a few assignments, and then the final project is the bulk of your grade. Okay, and then we follow this grading scale here. I'll never make anything that's harder than this scale. So for example, I'll never say a 99 to 100 is an A, and anything less is an A minus, but I could round this down to 94. That's happened before. So that's just an idea of the range of scores for you. Okay, so the expectation is with the assignments, exams, project, etc., is that they're fair but reasonably difficult. So do make sure to start early, ask questions often, and earlier on in the process again is better for you. That's what I found. We talked about the late policy. Come speak to me. If you are having problems, don't make special deals with your classmates or the course staff. Just come talk to me if there's something really going on that's hindering your progress. But otherwise, 10% penalty. For your day off, not a big deal. I know stuff happens. We'll take care of it then. Your assignments do have to compile though. Otherwise, they simply don't do anything, so I can't give you any credit. Usually we're pretty fair about this, but you might get a penalty otherwise, and you have to make sure it compiles. Okay, if you do want to challenge something in your regrade, you have a week to do it from when you get your grade. Sort of no questions asked. If it's later than a week, that's up to you to be diligent and look at it. And there's definitely no regrades after the semester. There's no asking multiple members of the course for regrades. These are bullet points because folks have asked, and I just have to be fair to everybody. Okay, on the wait list, I want to highlight this one here. Sorry, I'll make the text bigger. If you are waitlisted and say within a reasonable position, say within 5 or so, do stay in the class, follow along with the material. That's sort of the gamble you're taking with being waitlisted. I don't have power to, create other sections, even if I've tried. So you just have to follow along and, try to do your best here. Okay. There's no extra credit in this class, but if you do go above and beyond the project, it's possible you could get more points. In-class work, can't be made up at later dates. Please complete it within a week while that module's sort of active. Lab time, again, we don't really have in-class lab time, but I do want to use those Mondays and Wednesdays when we're in class to prioritize lab questions and homework questions that benefit everybody who's attending. So if you have a side project or something, we'll have to schedule a separate office hour to talk about that. Okay, and finally, I tried to see everyone throughout the semester and office hours. So whether you'll have a question or just want to introduce yourself, it's just good to know how to get access to me. I don't have a physical office, obviously online, but just to know how to access me online, and let me know a little bit about how I can help you achieve your goals. Okay, so that's it for logistics. Now that you've watched that, let's resume here. Navigating the web page, so you figured out how to do that. There's actually only one button here, so I fixed that here, and sometimes I'll magically fix things. Okay, so there's the course website. You know where it is. Click the link and scroll around a little bit, and you should be good to go. Okay, so hopefully you have a laptop or machine to participate in the course. If you don't, let me know and we'll try to figure out something if this becomes a hindrance. The course text, there isn't a required one to say. I'll pick out some readings, but I would recommend that you pick up one of these texts. This one in particular is free, so I might choose some readings from it. But each of these 3 other ones just have generally good software engineering advice. In particular, the Martin Reddy book is probably the closest one if I was going to follow along an actual course text to what we're doing. It's in C++. It shows you things like design patterns, good design, documentation, testing strategies. This is actually a really good book just to be reading along in the class if you can get a copy of it. Pragmatic Programmer just has lots of great wisdom, so I'll occasionally take sound bites from it. And then this is a more heavy sort of software testing analysis book that's great. So pick one up. These are the ones I'd recommend. So again, you can get away without a textbook, but I would say one of these three in particular are worth the dollars. Even if you get them after the course and read them, you'll appreciate them. Okay, so those are the resources. My teaching style, again, this is a very hands-on class. We're going to build things, so be prepared for that. There's going to be plenty of opportunities to make mistakes. Don't be afraid to be wrong. We can review, whether that's in person or online or whatever. There's no problem there. So do try things. Don't be afraid to break your code, and then you can always fix it. Do ask questions during office hours or on Piazza. I like to pause, and I usually write down and note those questions. When we are synchronous or together, I don't randomly call on people. I don't do this in class either, but because I didn't like it as a student. But do feel free to participate. That's what we'll want to do. Okay, so come to the office hours. I think it'll be worth your time. As I mentioned, email is less preferred unless it's a personal matter. Otherwise, just message me on Piazza. I get a lot of emails, and sometimes they get lost. So I just try to organize everything in Piazza. That way it won't get lost. Okay, my fair warning, my disclaimer for all of my PowerPoint presentations. You'll see it today. You've already seen it, that these are not great PowerPoint presentations. I wouldn't present this at Apple's Worldwide Developer Conference, where they make beautiful presentations there. I break all the rules because I think these slides are a good deliverable for you. I hope that they read like a book in a sense. So that's why I try to put information on them. You'll see me move my cursor around to highlight things. But that's just my disclaimer. I think, and they've been practical, so students have told me they're helpful, so I will continue doing sort of more readable slides. And since you're online, you can always pause. Okay, so shall we begin? That's enough administrivia. Maybe you're playing this at 2x speed. That's all right. Just make sure you got all the information. And I think we're ready to go. Okay, so question to the audience is, who has used C++? And I'm sort of curious what you've actually heard about it. So this is something you can post in Piazza, but do take a moment to pause the video and just think about, what have you heard about C++? And if you've taken that brief pause and are with us, what have you heard? Go ahead and post it in Piazza. Chances are you've heard something like it's changed, it's a big language, it's super fast, maybe some of these different things. In this class, we're actually going to be using a specific version of C++ that's modern C++, meaning the C++ version that was released after 2011 and beyond. So by modern, we mean, 9 years ago, which is relatively still young for a language. But we're going to be using the most modern features of the language, where applicable or where they make sense. The old features are still totally fine. There's nothing wrong because it's old. But we're going to be learning the newer stuff as well. Okay. So C++ is ranked, number 4 by some metric as far as popular programming languages. So this should be a good thing, that you're learning something that's relevant and used in industry, and you can directly apply, after leaving this course. But again, if you've done a lot of Java, in this number 1 position, you never really want to be married to a specific piece of technology because it always changes, or it sort of you want to be able to think in different ways. So throughout your career, you'll learn a few different languages pretty well and know which one's the right language for different tools, or whatever software you're building. So C++ is typically the language of choice when developing any high-performance application, games, financial trading applications, simulations, etc. There's kind of some fun anecdotes here of companies that have, used scripting languages like PHP for the web, but eventually they just end up writing a little compiler or a tool that translates their PHP into C++ code to make it faster. So this has been sort of there's a bunch of these sort of stories. Hip Hop was at Facebook, one of their sort of compilers that did this. There's Python compilers that compile to C or C++ and do the same sort of trick. So eventually, everything boils down when you need performance to a C or C++ or some sort of compiled language to get speed. So again, C++ is sort of king of different domains like gaming, image processing, finance. Netflix is using it behind the scenes for streaming. Hulu, etc. Are going to be using a lot of C++ code. So where does the performance actually come from? It's not just the language or the syntax, but it's that it's a compiled language. The code is executed as opposed to being interpreted like in a language like Python. So because it's actual machine code, there's not that additional interpretation step, and it can run faster. Okay, so here's some benchmarks that sort of compare C++ with Java. So you can see, it's maybe twice as fast for this particular benchmark. And of course, this benchmark could be anything that favors one language or the other, but roughly speaking, C++ is the fastest language between C and C++. Okay, so the language itself, though, has pretty much all the features you'd want. It comes with batteries included, or another way to say that is it comes with a standard template library, which includes all the common data structures that you'd want to use: queues, links, linked lists, stacks, maps, trees, and so on. It also comes with various algorithms for sorting and so on. The language itself is very expressive. You can write in a procedural style. We're going to do a lot of object-oriented programming, but you can also write in a functional style with lambdas and sort of map-reduce paradigms and these different things. But the key is, I'm throwing a lot of these different words around that'll make sense to someone who's a programming language expert. Is you have this tool, has a bunch of features, but you don't have to use all of them. You get to select which ones are there. And what's nice about the language is it has a lot of those features, and you'll learn how to select which ones you need to build software or design good software. Okay, kind of a funny anecdote here is from the creator of C++, Bjarne Stroustrup. He said this, he made the language C++ after C and around the 70s or so. He said, C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. So that's kind of a funny, quote about the language. So it's not a perfect language. It doesn't have built-in security features like other languages. Large programs can be hard to track bugs, but they can also be, they are trackable, so we have tools for that. May not generate as small as programs as C. It's a bigger language. And you have to do stuff for large projects like wrestle with just how to compile it nicely, versus other languages, like Rust and so on have largely solved some of these problems. In some manner, or at least better than C++. Okay, so it's not the perfect language, but it's going to be the language we use, and it's going to have a lot of awesome stuff that you'll learn. Okay, so some daily wisdom here from the Pragmatic Programmer. So chapter 1, towards the very beginning, if you do get a chance to read this book, it's wonderful, one of the ones I've recommended, is, what distinguishes a pragmatic programmer, is this idea that you're always aware of the bigger picture. What is the actual software that you're trying to build? How are you going to design it, and so on. And then some of these things like language choice become truly secondary. Language is just sort of your means to do something. But be aware of the bigger picture. If you need something, a piece of software that's fast and executes quickly, you use C++, and then you can design it. So there's your daily wisdom from the Pragmatic Programmer here. Okay, so here I am popping in with the actual wisdom here, so you can see me. So again, don't worry about the languages, don't worry about the tools, choose the best you can. Remember that our goal is to build a good piece of software. Okay, So at this point, if you've been watching this video, this recording thus far, I want everyone to take a break if you haven't. Stretch every 40 minutes or so. But two tasks. I want everyone to go to the course webpage, so on this link here, and click on this link here for the Mana repository. So I'm going to do it with you. Go to Teaching, Foundation Software Engineering, scroll down, and click on the course Mana repo here. Okay, when you click on that, it's going to take you to this screen and start creating your repository. Okay, this is on github.com, so it says it's finished here. And then this URL here is going to be your personal private repository where you'll do all the work. That's where you'll get all the assignments. Okay, so I'm going to click on it, and you should see it populated already with assignment 1 and lab 1 at the least. Okay, so before you do that though, change your name here, because sometimes your GitHub name, mine is Mike Shaw, doesn't match your actual real name. So give me your real name here so I know who you are, who is working on this code, and then commit those changes. Let me actually follow my own lead here, Mike Shaw, and then actually commit those changes. And then from your repository, your lab 1 is where you'll be working today here. So you have your lab 1 instructions here that you can read through, and the deliverables, I'll get to those towards the end of the lecture, but just make sure everything has loaded up there. Okay, and if you've done that, then we can continue on after this short break. All right, and if you're back with us, I want to give us a little crash course into the C++ language. Now, disclaimer, let me put myself here with the disclaimer here. I'm going to run through these slides fast. The purpose is so you start getting exposed to the C++ language. I can start highlighting some of the different features, but your first lab today is really going to be about getting set up with the C++ language, learning a little bit about Git. Your first assignment will also be like that. In fact, your next lab and assignment also will follow. So I want to run through some of the C++ language, some of the features. You're probably not going to understand or absorb everything if it's your first time seeing the C++ language, especially with how fast I'm going to run through it. But you're welcome to pause. You can take some time to look at the examples and try to think of things in terms of what you've learned before in Java or Python or whatever other language you've come from. Okay, so with that, let's go ahead and run through some of the C++ language here. Okay, so your hello world in C++ looks like the following, where you include a library here. You have a main function that can take some arguments when you actually run the program, and you can print out from the standard library. This is your cout function, hello, and then standard end line here. Okay, so here's a more heavily annotated version of the same program with some of the same or syntactic sugar of the C++ language explained. I'm going to go ahead and show you how to do this quickly on the command line here. So let me open this up, make a big font for you so that you can see the sort of hello world. Actually, I'll do it side by side. I like using Tmux to split up my windows for my system students will know that. But let's go ahead and write hello.cpp. Oops, looks like I already have a version of it here. So let me just delete it. Okay, and we'll start writing hello world. So I always start with the main function. This is our entry point into the program. And the main function returns a value that tells us how our program exited. Return 0 is conventional for exited successfully. Okay, now we can't do anything super interesting yet because we don't have any libraries for input-output. So we have the input-output, that's I/O, and stream because we're going to sort of write out or stream out text to us. So this is the library for doing various text input and output operations in C++. So what I'm going to do then is the standard namespace, so std for standard, and then C output, and then these two stream operators, which are basically saying, hey, send text to the C console here, and this is part of the standard library, and whatever message we want to write. Hello class. Okay, and then we can put a semicolon and end it here. We can put a new line character to give a nice output here, or we can also do a new line character with the end line function here. Okay, so I'm going to save this in Vim. That's what I'm doing with colon W, and then let's compile this. Okay, so I'll use G++. This is hello CPP. Output the binary as hello, and I want to run the hello program like this. Okay, /hello. Now you're welcome to use whatever IDE you want for this course. I sort of have my disclaimers in the lab that I will use the terminal in part because it's easier to show on live demos. But I don't care what IDE you use. In fact, I'll probably show you several throughout the course. But for the most part, use whatever you want. Okay, so here's your hello world written and compiled. Okay. So again, C++ is a compiled language, so anytime I make a change, I have to make sure I save the file. So if I just do hello class with a bunch of exclamation marks, if I don't recompile the actual code, it doesn't make any changes. So I had to recompile there and rerun it. So just make sure you're aware of that if you're used to a scripting language like Python. Okay, so the compilation here is done on the terminal. It could be done through an IDE that could make this easier for you. But I did forget one thing. I said we're using modern C++. So I'm going to add a flag here, standard equals C++ 11. We're going to use at least C++ 11 here. It doesn't change anything in this example, but it gives us more sort of features that we can use if we use 11. Now you're welcome to use also 14, 17 as well. And some of you might even have 20 as well for 2020. So there's a C++ 2020, and it allows you to do, again, use more language features. So you're welcome to use whatever you want. I'll specify if there is a restriction. And when you're working with various teammates, you might have to make sure you use the same compilation here. Okay, so here's just an explanation of the things that we did before. Okay, now there is an aside that there are ways to organize code using namespaces. So usually we do this as a package in Java, for instance. But instead of having to write out the standard, I could just say using namespace standard here. And then I would not have to use this abbreviation here for the namespace here. Okay, I could compile it and it'll run just the same. The standard here, : tells me the scope of where to find this function here. So somewhere there is a namespace in C++ called standard, and then someone defined the cout function, the end line function, and so on. Okay, so that's just a little insight into what's going on. I almost never use this because I like to know where my libraries come from, but this is sort of like packages in Java. Okay, so as mentioned, there is a compilation process where you write code. The preprocessor runs. That means it handles anything with a pound sign in front of it, like loading a library or any textual replacements that have to be done. Then the code gets compiled by C++ into an object file or just a binary. A linker might bring in any external libraries. These are usually DLL files if you're on Windows, or shared object files on Linux. And then you can finally run your executable. Okay, so this is the general process that's followed. Okay, and voila, here is your compiled program. Okay, so some takeaways. Here, again, C++ is a compiled language. That's a good thing for performance. And we typically like performance. We're going to build a performance-based application in this course, so we need C++ for us. And this compilation step can actually be valuable to us as software engineers in some cases. So I want to show you where that's applicable. Okay, so C++, very briefly, supports the following primitive data types. Many of these you've probably seen in Java or Python, depending on what kind of data you want to represent: characters, integer types, floating points, booleans, etc. Okay. There's other data types like string, which we'll occasionally use, and there's more advanced data types that let you do things in parallel that you can also take advantage of. Okay, so here's hello world, again with different primitives. This time I'm including a float for storing some digits of pi. Again, this can print out what pi is. This prints out the status here. As noted with C++, we have to declare what the type is of our information. So C++ is what's known as a statically typed language, meaning when we compile it, we know that pi is a float because we've said, hey, this is a float. C++ also has the idea of const, meaning that this value can never change. So this is an additional qualifier on the data type on pi here that says, hey, this pi value cannot change. And this is a good thing. It's useful. It makes our programs that we write a little bit safer in the sense that this is immutable, so we have some guarantee of what this value will always be. Okay, functions in C++. Look, here's a function. Here's the square function. You can try writing this and see what happens. It returns a value, x times x, and the data type is an integer. So that's how that works. In C++, you need to declare your functions before you use them. So I need to declare that this square function exists before I use it here on line 14. And then the definition of this function is also included. So we've declared this function square that takes in an integer as a parameter and returns an int. And we have the actual return value here, but this is the actual work that's done in line 7. This is the definition or the body of the code. Okay, so just to make it really clear, here's an example where I've declared that a function exists. This is called a forward declaration of a function. I said, hey, square exists. So in my main, which is my program entry point, I have this function square here, and I can use it because I've declared that this function exists, and then later on I have the actual function definition, which says what does square actually do, what is the actual work, it's defined here. Okay, so sometimes we can improve the performance of our functions executions speed a little bit. If you're new to C++, again, just take one of these things at a time. As I mentioned, I'm going through them quick, sort of on purpose, just to show you there's a lot of cool features and how we sort of start thinking about things as a C++ programmer. But there's a little trick that we can do, again, using modern C++, is we can add a qualifier to this function called const_expr. So this says this is a constant expression, and it'll try to evaluate this function here, square of 5, at compile time. So before we even run our program, we can determine that, hey, the user put in 5 here, so if I just put 5 times 5, this is a constant expression. It's something that's not going to change. The square of 5 is always going to be 25, so why don't I just print out 25 here? So that's kind of a cool, compile time computation C++ can do. So you save a lot of performance there. So as a C++ programmer, you can think about what's going on during compile time and runtime. So compile time, before you run the code, when you hit enter after doing G++, whatever, to compile your program, and then runtime, when the program's actually running, okay? And we have more tricks to do things at compile time. This is a really powerful thing in C++, with something called an assertion. So let me show you what it means to statically evaluate something or assert something that should always be true. So here's a static assert. You might not have seen these in other languages. Again, this is fine. I'm just showing you lots of features here today. You're going to practice from the basics in the lab, but a static assert says, hey, the size of an integer here should be 4 bytes. If it's not, you'll get a message at compile time that says int is not 4 on this architecture. This tells you, again, as soon as you try to compile your program, that int is something other than 8 bytes. So this one passed. Integer is indeed 4, but it's not 8 here. So this is kind of a fun example just to check what size your data is, because sometimes they vary on different machines. So you can test things before your program even runs, which is a nice testing strategy. And we'll do some of this in a few weeks. Okay, in C++, as I mentioned, it's a statically typed language, meaning when we say, hey, something that's a float is a float, or something that's an integer is an integer because we declared it as one. So here's an example, int a is an integer. But you can cast that value statically. So I can say, hey, I have this long, which is basically a really big integer, equals 9, but I want to cast it to be something small here, just 4 bytes of information. And then you can print it out, okay? So you can do this before the program runs at compile time, if it matters that this is known to be just a 4-byte integer. Or if you don't care and want to just evaluate this at runtime, you can do this sort of cast. So again, static, we're thinking about things that happen at compile time, and when we're just evaluating a function here, we can think about things that happen at runtime. So again, just thinking about different static versus runtime in C++. Okay, so we have some data. Now where can we access these different pieces of data? Scope really matters in C++. So it's a curly brace language, same rules as Java for when a variable is alive or when you can access it. So sort of the aliveness of variable. It's sort of lifetime, if you will. That this x equals 7 goes away after here, this x equals 5 goes away by line 10. Okay, right where it leaves the matching curly brace. Okay, so here's some examples with objects. So if you've used object-oriented languages like Java, here's some object here. I have a class. That's how we create different data types in C++. I have to say what's publicly accessible. By default, everything in a class is private. So public. Here's the constructor, the first thing that's called when we create a function. So it says created or destroyed. So if I put this object in these curly braces, which define its scope, as soon as I reach line 17, I'm going to get destroyed. So when this object is first created here or initialized, the constructor is called and I get created. And then by line 17, it's automatically destroyed, and the destructor is called when it leaves scope. Okay, so this object here is on the stack. Okay, and there's no memory allocated. There's no malloc that's used like in C. There's no new used like in Java. So it's just a stack allocated object. And when it leaves scope, when it leaves these curly braces, its destructor is called, and you can reclaim any memory. Okay, because in C++ we have to manage our memory, so we don't want to have any memory leaks. Okay. So 2 ideas introduced on this slide, what a class is and objects, and then stack allocated data. So again, a lot of ideas here, so let's just try to break it down a little bit more. And again, by week, I would say around 3, these will start making much more sense once we get to practice. But again, I want to give you the high-level overview. So building custom data types with classes. Class, again, has attributes, that's the data, or member variables, we call them in C++, and then the behaviors, the actual code or functions. You know these as methods in a language like Java. We call them member functions in C++. Okay, so class is just a specification of how instances of that class operate. Okay, so here's a class example in C++ where I have something called a game object. I like using game examples here. We can have an instance of a game object called Mario. Here's another instance called Luigi. So these are separate game objects. Their data type or their type, Luigi is a game object. Okay, Mario and Luigi are instances. They're separate instances of game objects. Okay, so the structure of C++ programs, and this will be something a little bit new, is that we have interfaces which are put into separate files completely called header files. that sort of define our interfaces, and then implementations of those interfaces, which are just regular C++ files with the CPP extension. Okay, and then usually we have a main.cpp that has the main function and is our entry point. Okay, so let me give you an example where we have some of these files here. So I'm going to have a header file here at the top, right here, and this is the interface. It has the class. It sort of has the declarations of these functions, maybe the so declaration of the constructor here, declaration of the destructor, maybe any member variables here that are the data. It's just the interface here. And then I implement that interface in the equivalent or the sort of matching game object.cpp. I can name these whatever I want, but usually I name them the same thing. So I include game object.h, so I know about this interface here. And then I define the functions that have been declared here. So the scope is, or the function I'm defining is game object : that's that scope operator here that says, hey, where can I find this function game object? Oh, it's in the game object class, so that's why there's : here. And then I just assign it a value from one of its member variables. And then I do the same thing for the destructor. See the squiggly or tilde game object. It's the destructor here, special syntax for the destructor. That is called automatically when an object is deleted or leaves scope. And then where can I find it? Game object : just the scope operator. Okay, now here's an example with a few Vim windows open. So what we looked at there is just on the left. Here's a game object.h file, the header file, and a game object.cpp file. And if I want to bring these all into a project, say I have where this main file is, I do the clang compile. We're using C++11. My C++ files here are what actually gets compiled, and then I output, the binary that'll get run. The header file doesn't get compiled because it's just an interface. It's included in your C++ file. So if it hasn't, it gets included once. Because I have these what are called header guards here that just define game object, this sort of value that exists. If it doesn't exist, create it once, and then have the interface here in this file, and then the actual code that does the work is here. Okay, so a couple ideas here. Again, we'll practice in Lab 2 doing more object-oriented development. Okay, so C++ also has structs. We've used the class keyword here, but there is an actual difference between a class and a struct in C++. Does anybody know? Go ahead and pause the video if you know, and give yourself some time to think about it or actually Google it. Okay, and if you weren't sure, it has to do with the privacy level. So the privacy level is public in a struct and private in classes, okay? So my best practice advice, again, this varies from person to person, company to company, is you use structs as a piece of data or just an aggregated type, and then you use a class otherwise by default in C++. So that'll sort of be my rule of thumb. Again, it can vary, but that's what we will do in this course. Generally, again, we like classes because they enforce good practice known as encapsulation, where I only really have to know what functions do within the class. I can hide the intricate implementation details. I can hide the state of an object from a user. And with classes, I can also build on top of each other to become more powerful. Okay. I briefly want to talk about this idea of inheritance. This idea that you can build classes from others that have been defined. Here's sort of a classic shape example that folks use. So shape is sort of the base class. A rectangle is a shape. A triangle is a shape. A circle is a shape. And all of these three classes that are derived from this base class shape here might share various properties. They all have a perimeter or an area for each of these rectangle, triangle, and circle. Okay, so the idea is we can use inheritance to get some sort of code reuse is one way to think of it, but also just because a rectangle is a shape, and it's sort of, the shape is a almost interface for each of these derived classes. Okay, so we can also in C++ do something known as multiple inheritance. This is new. This is something you can't do in Java. You can't do it in Java because there's a problem with it, apparently. So I'm going to let you pause and try to figure out what's going on weird with this design here. So go ahead and pause the video and take a moment to think about it. Okay, so the problem is this is actually known as what's called the deadly diamond inheritance pattern. That is, class A here is the sort of base class, but class B and class C are both derived from it. But then class D here is derived from class B and class C. So if class B and class C have two functions with the same function signature, two of the same member functions, maybe they're called foo or whatever, class D just picks one to inherit. So it's inheriting properties from both of these classes here, but if they're named the same thing with the same signature, it just picks one, and that can be a problem that unfortunately is sort of undefined behavior, which we don't like in our software. We want our software to do the thing that we said it's going to do. So we shy away from multiple inheritance in C++. It's a feature that's largely protected against in more modern languages. Okay. So another feature I want to talk about is called polymorphism in C++. Maybe again you've seen this in Java, but this is a feature that allows a collection of types to be manipulated through a common interface. In C++, this is typically done through the virtual keyword. It's a little bit easier if I show an example, but what it means is shape is sort of our interface here. It's a base class, and these other classes that are deriving from shape, again, might have a different way to compute the area. Okay. There's another term for this, polymorphic functions, meaning you can have the function named the same but with different parameters. Okay. We'll talk a little bit more about virtual functions and some of these things, but just know that C++ supports different types of polymorphism, whether when it's inheriting different functions from classes, you can sort of change the behavior, so it's sort of morphing, and with function polymorphism, where I can have a function named square and then a different data type. Okay, so that was one of the big ideas with classes. We touched on inheritance, what an instance of an object is, and sort of how we structure our C++ programs. Again, if you've made it this far into the lecture and are like, wow, Mike, I'm overwhelmed, just sit tight. We're going to break this down, and once we practice it, we'll actually get a little bit more comfortable with things. But I just want to show you what the language is at a high level, and we will dive into it. So, stick with me. And let's talk about this next idea of stack allocated data, and a few other things here with memory management. This is going to be a little bit of a review from systems for folks who have taken a systems course, but when we allocate memory, it's typically in two places, in the stack and the heap. In C++, we have to manage memory that's allocated in the heap. In the C language, we did that with malloc and free. In C++, we do that equivalently, but with the words new and delete. Okay. This is just going to be a review of pointers. For your lab 1, you're going to do a video lesson on pointers. Just again, I think hands-on practice helps, or if you're a little rusty from systems or haven't used pointers in a while, this is how they work. But basically you have, I'll run through this very quickly, memory. It has an address, and you can point to these addresses using something called a pointer. Okay, so if you want the address of something, you can use the ampersand operator, which tells you where this X, this 4 bytes of actual information lives here. Okay. In C++, you can pass you pass by value just like in C. So here's X here. If I pass in 42, it passes in a copy of this value X here in the stack. So its scope is based off of these curly braces, and it's going to set that value X equal to 42, but when it leaves scope, that copy gets deleted, so X will be 42. It will not have changed to 9999 because pass by value is just copying a value into the function and manipulating that copy as opposed to actually changing it and preserving that change. So instead, in C++, something that we can do is, well, we can do the same thing as we did in C where we made this a pointer, but in C++, what's new is we can actually pass in by reference by putting in the ampersand here in our function signature, and it will pass the address of where X lives here and manipulate that. Okay, so now if we run this, X is now 99999. Okay, and this is a new C++ thing where we can pass by reference by just passing the address of a variable here. It doesn't make a copy, it passes the actual address of this X here, and then X is set equal to 9999. You can think of this A as an alias here, and then the value is reset. Okay, so pass by reference here, and here's just a sort of note on it. Okay, so we still have our other tool as mentioned in C, raw pointers. Pointers are just a data type. Pointer is a variable that holds a memory address. The address is the value stored. Okay, so I'm going to fly through the pointers review because that's what you're going to do in your lab today. And many of you have already seen these slides in systems. We want to initialize things. You have to point to an address. That's what pointers point to. You can verify it by printing out the address. These examples themselves are in C. And if you want the value of the thing that you're pointing to, you have to dereference it with the asterisk. Okay, so here's an example of dereferencing here, the pointer. Okay, so here's another example. Do pause the video and try this one out. You can do it in C or try with C++ with the IO stream here, and try to figure out what this value is. Okay, and if you're joining back with us, my systems students have probably seen this before. We set X equal to 5. We have created a pointer here. I'm going to prefix my pointers with P, set it to the address of X, so it's pointing to whatever X has stored into it. Print out the original value of X. X is 5. When P points to X, and I'm going to dereference it, that means grab the value of the thing that I'm pointing to and update it to 100, so this should be 100. Okay, after I modify the value here, I dereference what I'm pointing to. Dereference says, hey, get rid of the sort of reference, the thing I'm referencing, just give me the actual value and change it. Okay, so why do we like pointers? They're usually a little bit more efficient to pass around. They're small copies. They're just making a copy of the memory address, so they're relatively efficient. So we like them in general. Okay, now we need to be a little bit careful when we use pointers, or one reason why we need to use them, again, is this last note here that we use them to point to a chunk of memory, and that memory is allocated on the heap. Okay, so pointers aren't magic, they're fun, they give us a lot of power for how we can pass things around. Okay, so let's get to that last point on dynamic memory management in C++. So again, in C we used malloc and free. In C++ we use the new keyword that allows us to allocate memory on the heap, and then we have to delete it when we're done. Same rules apply. It sounds like it's a sort of pain to do, but the advantage is it gives us a lot of control in our C++ programs. Allows us to build data structures, pass around data more efficiently, grab as much memory as we need at runtime when we don't know how much we might not exactly need, so that's why we need new and delete. Okay, so here's an example where we might allocate memory for this custom data type here. It's a vector 3 with x, y, and z. I allocate with new here, and then I delete. Okay, because I have to reclaim any memory that I've allocated. Here's another example where this time I've allocated 50 of these vectors. But this time when I delete, I need to include the brackets here, and that indicates that I want to delete this whole array, all 50. If I don't have these brackets here, these two square braces, then it'll just delete the first item in my array here rather than all of them. Okay, so those are the observations that are posted here. So again, make sure to use the brackets when you're using arrays. That'll save you a lot of headaches. Okay, there are something called smart pointers in C++. We'll talk about that with resource management. That's a big part of software engineering, but that's gonna come in another day. If you're used to Java, you didn't have to worry about some of these things because the memory was managed for you, but because Java's spending so much time managing that memory for you, you lose a lot of performance. That's where a lot of the performance is dropped. Okay, here's the different types of smart pointers. We'll talk about these later. Okay, so we're getting close to the end. The wisdom here is you write good classes, create good interfaces that are sort of clean, and I've shown you the main features of C++, pretty much everything that you're going to need to use in this class. Any of the fancier stuff is sort of optional, but now you've got a good handle on, or at least a overview of all the things that you'll need to know. Some of it builds on your C or Java knowledge, but this is really all the main features that you need to know in the language. Okay, so nice set of tutorials you can walk through are on cplus.com. I'll leave that as a resource for you, and you can go through it. So your first homework will be to actually review some C++. Okay, so where are we going to do all this work? Well, we're going to do it in GitHub, as mentioned. So again, I showed a example of that. This is from one of my courses. This is what yours will look like. Just a little review on Git. This will be what you do for your lab if you need some practice with Git. There's a wonderful 30-minute tutorial here on how it works. I'll be reviewing it and some of the lab write-ups. Basically, you've got a working directory on your machine. There's a repository somewhere out in the world for us, hosted on github.com. We want to get it to our working directory, so we check out the project. We make some fixes and change it locally on our machine, and then we commit those fixes or the code that we've modified, and we push it to a repository on the World Wide Web for all of us to share. So there's a little cheat sheet here if you need help. I think I've included it in the repository. But again, if you're a little rusty on your Git, we'll be doing practice, but you can get a nice tutorial here as well. Okay, so now at this opportunity, we're running close to the end of our time. Again, not all of our video lectures will actually be this long, but this is a longer one. But here's our in-class activity. So make sure, again, you go to the home page, teaching, whatever module we're working on, module 1 here. You have a week to complete the in-class activity from when this is released. Okay. So with that, we'll move to lab. Again, labs are found in the Mana repository. Typically, they take between 1 and 3 hours to finish. We'll have class time to do it. That's on your Wednesdays typically. If you're in the class, you can work in pairs. Typically the first labs I want people doing individually, just so everybody learns and gets practice. Obviously we're virtual, so I'm not walking around and helping you, but I'm on a screen and going to try to help you move forward that way. Okay, so again, you have your Mana repo. You should be using your just a private GitHub account. If you need to create one, you're welcome to do that. So whatever credentials you like, that the repository that you create will be private to you, and you can use that login. And every week, just do a git pull when you're about to work in your repository in case I push something to it. So typically the Monday or so of class, that's good to do a git pull there. And please don't ever share or post your repository publicly. Okay, this is your work, and we want to protect it. Okay, so here's just some instructions on creating your GitHub repository. Do a git clone with your repository, whatever it is. You'll find it here. Do a git pull just to make sure it's up to date. And then you can begin. Okay. Some tips on using Git. As you make changes to your project, Git status is super helpful. just to make sure, again, what branch you're on. We'll talk about branching in this first lab, and make sure your repository is up to date here. Okay. Okay. You can think of get status sort of like a query, asking, are my files up to date on my local machine to what's on the repository, and then just, doing that frequently helps resolve any discrepancies. Okay, and then as you make changes, add those changes, commit those changes, and push those changes forward. Okay, that's sort of like sending mail. Okay, so with that, I now run through a bunch of slides here in a little bit of time. So let me go ahead and put myself back on the screen here. And just say, again, welcome to the class. We're going to have a lot of fun. We're going to learn a lot of things. Today was probably a lot of stuff, so you can watch the video twice if you need to. And again, I just want to I realize it's a lot of stuff, and we're going to practice some of these things more in depth. But now you should have an overview of some of the C++ language, things that are important, compile time versus runtime, classes, organizing your code, thinking about structure of inheritance. We're going to get practice with those things by building a project. So again, welcome to class. You'll find this video. Let me go ahead and get rid of me here. On the course website, of course you're already watching it, but again, videos will always be posted here, or when you go into the module, the video for that module will be directly linked here. Okay, so that's all I've got for you, and welcome again to class.